Hi everyone. Today we have two speakers. One it's Sander and Edwin. They are architect in info support company. Igor?
Yeah, and we also have this as a full day workshop. Well, full day means like 2 sessions for the 75 minutes. And Edwin Zander, so yesterday you gave a talk about Dapper. So today we are going to like really understand what Dapper is and how to use it, right?
Yes, exactly. So the session that we did yesterday was on the more advanced topics within Dapr, like security and integrating with Azure services. And today we want to go back to the basics and learn people how you can apply Dapr to a microservices application step by step.
Okay, and what's your experience? So I believe you made this workshop before. So is it kind of, how do you feel about doing it online? It's a little bit, unusual setup for workshops.
Yeah, it's certainly different because if you're in a room with people doing the workshop, you really get a feel of the room and on what part people are succeeding, where they need help. It's very easy to do discussions, and that's very different with a virtual conference. But luckily, we have this chat channel with Telegram, so people will be able to ask us any questions. If we see that multiple people have the same questions, we can just go to video and explain some stuff, share our screen. So I think we'll manage, but it's certainly different and a little bit more difficult doing it virtually.
Okay, but I'm sure we'll succeed because, well, I know that you have a very good preparation and everything is like ideal and well prepared. So a little bit to the structure. So I believe you will give some introduction first, and then we will go to the hands-on part.
Yes, exactly. Yes. So we're going to do a small wrap up of what Dapr is, so to give people a little bit of understanding, and then we will share also the place where you can download the workshop, the documents, and then you can start working on it. So yeah, it's correct.
Okay, so I think then we should just go and start the learning curve, the learning path, sorry, and let's see where we are by the time we end in 2.5 hours.
Yeah, looking forward to it.
Let's dive right in. Yeah, so as Igor said, my name is Sander and I'm joined by Edwin. So this is a workshop to give you really hands-on experience with Dapr. We really believe that you learn best by just doing it yourself, trying out things yourself. So that's what we are going to do. And it's basically a self-paced workshop. So first we will give a really quick Dapr introduction, just so that you know the fundamental concepts and we're all on the same page. And then after that, Edwin will talk about traffic control. And for those of you who've seen the advanced session yesterday, that will be familiar to you because we also used that sample in our breakout session yesterday. So Edwin will give a little bit of introduction on that, and then we'll dive just direct into the hands-on part. And as I said, that is completely self-paced, self-explanatory. We will give you all the links that you need for that part. And then if you have any questions during the hands-on, or maybe not even a question, but something you like to know more about or like to discuss with us, please feel free, don't hesitate to put anything that's on your mind in the Telegram chat. And we can answer that and start some discussion around that. So what's this Dapr thing that we're talking about? So Dapr is a distributed application runtime. It's an open source project that was initiated by the Azure incubation team within Microsoft. But since then, it's also been handed over to the CNCF. So it's a real open source, vendor neutral project. And the goal of Dapr is basically to just make it easier for you as a developer to build microservice applications. Right? Once you get into microservice or cloud native or distributed, however you want to call these things, once you get into this type of architecture, those are pretty complex architectures usually, and you run into some problems over and over again. And Dapr provides you with building blocks which are basically out-of-the-box solutions for those type of problems. So here at the bottom of this slide, you can see the basic building blocks that Dapr currently provides. By the way, we are in version 1.1, Dapr G8 in, I think it was mid-February. So it's pretty early days still, and future versions of Dapr will incorporate more of these building blocks. But if you need to introduce these quickly to you, so from left to right, first of all, we have a service to service or just a service invocation building block, which makes it possible for you to call a microservice from a different microservice. And the Dapr ensures that service discovery is done for you, so you don't need to know where exactly these services live. All that name resolution is being done for you. And Dapr also provides you a secure channel between these services, and it provides you observability so that you get automatic logging of your service requests. Then you have state management, which basically helps you create these stateful long-running processes. And this is mostly about transactional or hot state. So if you've got like a process manager type of component and it needs to store some transactional state, then the Dapr state management is great for that. In a different sample application, we use it to store the state of a shopping basket in an e-commerce scenario. So those kinds of small hot state scenarios, that's perfect for state management because it offers you a key value store. So don't try to put a whole relational data model in a key value store, but for that transactional state is perfect. And then we have the publish and subscribe. So where the service invocation building block provides you with a synchronous, a direct service call, publish and subscribe gives you pub/sub semantics. So that's asynchronous messaging between services. And here you can inject all kinds of different message brokers, such as RabbitMQ, Kafka, Service Bus, Azure Service Bus. And then Dapr provides an abstraction layer on top of that. Resource bindings and triggers are very similar to the way that triggers and bindings work in Azure Functions. So those can abstract away some of the implementation details you need to know if you want to interact with an external system, and just makes it really easy to communicate with external systems. Then you have a complete, fully featured actor model. So the actor model, it's very interesting if you want to have a single-threaded execution model. It treats an actor is basically a unit of compute and storage, and they communicate via messaging. And every actor can handle at most one request at a time. So if you are working in highly concurrent scenarios, the actor model makes it very easy to deal with that concurrency by using a single-threaded or turn-based access model. And then we have some more supportive building blocks, such as observability, which allow you to get all kinds of distributed tracing and logging and metrics out of your system, and put it in a tool like the Elk Stack or Seek or Zipkin. There's a secret management block, which you can use to manage your secrets. And then the good thing to know is that these building blocks are extensible. So these building blocks basically provide you with an API that you program against. And then there are Dapr components which provide you with an implementation. And that makes for a really flexible solution, because I can change the component. If I use the pub/sub building block and I want to use RabbitMQ in my test environment, then maybe in a production environment, I want to switch that to Azure Service Bus. And I can do that without making any change to my code. Now, these APIs, these building block APIs, are offered both over HTTP and gRPC. And because of that, you can run Dapr basically on any platform where you can make HTTP or gRPC calls. So it's very open. But of course, if you're working in a certain language, you would probably prefer to have a language native experience. And for that, there are language specific SDKs that you can include with your program and use. And then one of the other interesting things that we're starting to see is Dapr showing up inside of other Azure services and having better integration with other services. So Edwin, for example, yesterday in the breakout session, he showed integration with logic apps and API management. So if you're interested in that, maybe check out that recording. Now, one of the most important things to realize about Dapr is how it runs. So Dapr is not a library or a file or something that you include in your application code. Instead, it runs besides your application code in its own process. So here on the top of the slide, you see what we call the self-hosted scenario, where your application code runs in its own process and Dapr runs in a separate process. And the communication occurs through either HTTP or gRPC. Now, for production scenarios, the team actually recommends that you host this in Kubernetes. And in that case, your application code would be hosted in a container, and Dapr would run in a different container. So this pattern is often called a sidecar pattern, where Dapr runs as a sidecar to your main application. And both of those containers would run in a single pod in Kubernetes. So let's look at a quick example for this. So let's say I have a Service A pod, and in the Service A pod, there runs my application container together with its Dapper sidecar. And that's, by the way, very easy to set up in Kubernetes. You just add a annotation to your Kubernetes manifest, and then Dapr will automatically inject that sidecar into your pod. So once that's up and running, I can now use all the building blocks from Dapr for my application. And it's not a nothing or everything scenario. I can choose to use only one of the building blocks, or I can choose to use 3 of the building blocks or all of the building blocks. Don't feel obligated to use every tool in the box when you use Dapr. So in this example, my application uses the state management building block to save some key value pairs, basically. And then I need a component configuration file to tell Dapr which component I'd like to plug into that state management building block to actually store the state, to act as the backend state store. So in this case, I've configured Dapr to use Redis as the backend store. So now every time my application code updates the state, Dapr will store it in the Redis state store. And I can change that. I can change that very easily by just making a change to that configuration file. So for example, if I want to store it in Cosmos DB, I just change the component configuration, and then from that point on, Dapr will save it in Cosmos DB. And I think that's pretty useful for 2 scenarios. So first of all, for scenarios where maybe you don't want to make all your technical decisions up front, and you start small, and a really small single instance database is good enough for your application. And then later on, you either need to migrate or you need to switch to an infrastructure that offers better performance. You can change that very easily. But also within your development process, just going through dev, test, acceptance, and production, it can be very useful to use a different database in your test environment or your development environment than in your acceptance or production environment. So let's look at another example. Let's say this Service A needs to call a Service B. So how does that work? Well, instead of directly calling the Service B application, Service A will make a call to its local sidecar, and it will tell its local sidecar, please call this other servers on my behalf. So the local sidecar will automatically discover where the remote service lives, on which pod node it lives. It will make a call to its sidecar, and then that remote sidecar will make a call into the application. And then, of course, if the Service B has a response, it will flow back the same way. Now, because these sidecars were injected, if you can go back one slide for just a minute, Edwin, because these sidecars were injected, Dapr can inject functionality here. So for example, if that call fails to service B, then the Dapr sidecar can automatically apply some retry logic for you. So that's very useful to have that layer in between. Okay, so I've already talked about some of the components. This slide is now, I think, 2 months old. So there are even more components available now for Dapr. As you can see here, there's just a lot of choice in infrastructure and middleware that you can plug into these building blocks. And that's still growing because there's a very nice, vibrant community around Dapr. Now, the other thing we want to quickly show you is eShop, because when Edwin and I started playing around with Dapr, we wanted to know, hey, does it really make it easier to build microservice applications? Because that's basically the promise of Dapr, and you can try it out in small samples, but you don't really get a feel for it unless you apply it in a larger application. So what we did was there is this .NET reference application which was created by Microsoft, and it's called eShop. And there are a couple of versions of it, and one of the versions was called eShop on containers, which you can see on the left. So we took that version and we basically applied the Dapr building blocks to it. And then we looked at the differences, like, is it easier to maintain? Is it less lines of code? Are we more flexible now? And we called that new version eShop on Dapr, and it's available for you to look at on the Microsoft.NET Architecture repository. And we also wrote an ebook about it together with somebody from Microsoft. That's called Dapr for .NET developers. So it's mostly focused on .NET developers, but we had a colleague who read it who's writing code in Java, and he found it useful as well. So I guess there's some stuff in there that's not just for .NET developers. This ebook's totally free. So if you're interested in reading more about that reference case, you can go to these URLs and you can download the ebook over there. So that basically concludes my quick introduction of Dapr. So now I will switch to you, Edwin, for your introduction of the Dapr traffic control sample.
The Dapr traffic control sample, for the people that were at the advanced Dapr session, we already introduced this sample. And what this is basically a simulation of something that we have on a lot of our Dutch highways. So this is basically a speed trap. So that means that if you drive on this stretch of highway, there are some cameras that are above it. And if you drive under the entry cam, it will take a picture of your car and, of course, your license number, and it will store that in a central system. And then once you leave this stretch of highway and you drive under the exit cam, it does the same thing. And then the system has two timestamps. So the timestamp that you entered this stretch of highway and the timestamp at which you exited this stretch of highway. And then it can calculate the average speed. And if the average speed that you drove is higher than what is expected or what is allowed here, then you will automatically be fined. So you get an email or you get some letter from the government that says that you have to pay this fine because you did a speeding violation. So this is actually a completely automated system, and this is what we've built in a small simulation as our sample application. And why we chose this is that this domain is pretty simple, right? So it's only a couple of services, and then I will show them in a minute. But it is really simple to grasp. There are not a lot of business logic in there. You just have the camera, you have some logic to calculate the average speed, and then based on the speeding violation, you have to calculate the fine, and that's basically it. So the services that we created to simulate this are shown below this picture. So we have a camera simulation that is just basically simulating cars driving under these cameras. And then we have the traffic control service. And this is the central system that will get these messages. So it will get messages for each car that drives under the entry cam or under the exit cam. And it does this by sending a message to an HTTP endpoint, in this case, /entry cam or /exit cam. And this way we simulate cars coming into the system. So the traffic control service stores its state when a car has been registered. It stores its state, and then once it has calculated the average speed and there's a speeding violation going on here, it will send a message to the fine collection service. And the fine collection service has an endpoint /collect fine, and it will send a speeding violation to this endpoint. And then the fine collection service will basically do two things, or basically three. So it will calculate the fine. So based on the amount of the speeding violation, how many kilometers an hour you drove faster than is allowed, it will get the information of the vehicle and its owner from the vehicle registration service. And this is the last service that you see on the right. So it can call an endpoint over HTTP /vehicle info and then / the license number of the car, and it will get back the information of the vehicle and its owner. And once it has done that, it will send an email with the fine to the owner of the vehicle. So that's basically all the functionality that is in the sample application. So in order to teach you with this workshop how you can apply Dapper to this, we have created this setup, what you see here. So the camera simulation is just a .NET application. Everything is .NET Core, by the way. So all the code that you will see in the workshop is .NET code, .NET 5. And the camera simulation will just be a .NET process that I start using .NET Run. All the other services, so the traffic control service, the fine collection service, and the vehicle registration service, all are started with a Dapper sidecar. So they run with Dapper, and they are, as we call it, Dapperized or Dapper enabled. So now we can start using all these building blocks that Sander introduced in his introduction to communicate between all these services. And the first building block that we're going to use is service invocation. The service invocation building block will be used once the collect fine has been sent, and the fine collection service needs to get the vehicle information and the owner information for the speeding vehicle. It will use the service invocation building block to call the vehicle registration service. So instead of that being a direct HTTP call to that service, it will do that through the Dapper sidecar. And as Sander explained, it doesn't need to know where it lives, and Dapper will take care of all the communication and all the heavy lifting over a secure connection. So that's the first building block. And while I'm doing this, all these building blocks, also in the order that I'm introducing them now, you will be applying them to this solution during the workshop. So every assignment, you will get a new building block added to the solution, and you have a description how to implement that and add it to the necessary services. So what's the second building block that we're going to add? Well, that is pubs up, publish, subscribe. So when the traffic control service has calculated the average speed and it has detected that it is a speeding violation, then it will use pubs up to send this message, the speeding violation, to the fine collection service. And during the workshop, you're going to use RabbitMQ as a message broker that will pick up this message, and then the Dapper sidecar of the fine collection service will pick up this message from RabbitMQ, and then it will call the collect fine endpoint. You will actually start running RabbitMQ during the workshop. This is all Dockerized, so it's all running in containers, and there's all description in the workshop how to set that up. The third building block we're going to use is the state management building block. And as Sander already explained in the example in the beginning, we will use Redis cache as our state store. So every time a car has been registered because it drove under the entry or exit cam, the traffic control service will use the state management building block to store its state in Redis. Then we have an output binding. We've talked about bindings, and bindings can be either input or output bindings. And in this case, it's an output binding because we're going to use an SMTP output binding to actually send an email to an SMTP server. And this is done from the fine collection service because this service is responsible for sending the email containing the fine to the owner of the vehicle. We're also going to use an input binding, and we are going to use an MQTT binding. So MQTT is a lightweight messaging protocol, and we're going to use a MQTT broker called Mosquito. And the camera simulation will actually send MQTT messages to this broker, to this Mosquito MQTT broker. And then the Dapper sidecar of the traffic control service will subscribe to messages on this broker. And every time a message comes in, it will send it to the necessary endpoint. So this is the input binding that we're going to use. And then finally, because we have to connect to the SMTP server and there's something going on with an API key, we also going to use the secrets management building block to securely store the secret that you have for connecting to the SMTP server, like the credentials, the username, and the password, to securely use that using the Dapper secrets management building block. So although this is a very simple solution, it doesn't do a lot. You can see that we've used a lot of building blocks, and we've squeezed in a lot of building blocks because there are lots of infrastructural components going on here. So our pub/sub is now abstracted by Dapper. We have an SMTP server, but we don't need to know anything about SMTP. We just call the output binding and it will send the email. So you see that all these green blocks in the middle are abstracted by Dapper. And although this is not in the workshop, but if you have executed one of the assignments, for instance, adding pub/sub with RabbitMQ, you could, of course, for yourself also define a separate assignment to use a different broker, to use Nets, for instance, or even Azure Service Bus if you would like to do that. And the only thing that you need to change then is the Dapper configuration for that building block. So that's something that you could do if you would like to go a little bit further than the workshop. But in the workshop, these are the infrastructural components that we're going to use. All these pictures that I've just shown you are also in the workshop. So they will be repeated, and we will take you step by step through it. So let me show you the application now. So I've switched to my Visual Studio Code, and you see all the services in here. So there's the simulation, there's the traffic control service, the fine collection service, and the vehicle registration service. And let's look at the traffic control service. As you can see, this is just an ASP.NET Core web application, web API, so to speak. It has a controller, and this controller is quite simple because, yeah, like I said, there's not a lot of functionality in here. It's just, simple code. There's no voodoo going on here. It's just, if you know a little bit of .NET, you will understand this. Also, what is in here, and that is important to understand, is that this also can run in Kubernetes. So we have the self-hosted version and we have the Kubernetes version. And for now, I'm going to show you the Kubernetes version. But during the workshop, you will do the self-hosted one, but I also wanted to show that. And I opened this folder, the Kubernetes folder or the K8s folder, and here you see all the configuration files to roll out this solution onto a Kubernetes cluster. And I'm running Docker Desktop on this machine with Kubernetes enabled. And just as Sander said before, if I look, for instance, to, let's say, the vehicle registration service, then this is a typical manifest file that you use to deploy a service to Kubernetes. So in this case, it's a deployment. It is the vehicle registration service, and everything is running in the Dapper traffic control namespace. And if I go down a little bit, then you see here a couple of annotations that are not Kubernetes, but these are Dapper specific. So if I wouldn't add these annotations, this would just be an ASP.NET Core web API that is running in Kubernetes in a container. But because I added these annotations, now it becomes a service with a Dapper sidecar. And everything that happens under the cover, so all the communication with the servers will now be done through the Dapper sidecar. And what's very important to note here is that this is, for instance, the application ID. And this is the unique application ID that Dapper will use to find this service. So if I want to do, for instance, service invocation onto this service, I need to use this application ID. So that's really important. So let me show you the logging that you will see also during the workshop. I will start it now. And like I said, this runs in Kubernetes. During the workshop, you're going to do something different, but I just wanted to show you this. So I'm going to start this, and it will just apply all these manifest files. So also the RabbitMQ and the Redis cache and the Mosquito broker, all that stuff is created on my Kubernetes cluster. And what I can do now, I go to a terminal and I'm going to start K9S, which is a very cool tool to look at your Kubernetes cluster. So you see all the services here that we've talked about, and well, they're up and running now, so everything is green. So for instance, if I go to the simulation, so this is the camera simulation service, and I go to that and I look at the logging, then you will see that it's just simulating cars driving under entry or exit cams on a certain lane. So what happens under the covers here is that this service will send MQTT messages to the Mosquito broker for every entry that you see here. And then when I go back and I go to the traffic control service, because that is subscribed to the Mosquito message broker, it will receive these MQTT messages. So if I now go to the logging of this service, and here you can see, by the way, that within this pod, so within this deployment of the traffic control service, I have two containers running. I have the Dapr D, which is the Dapr sidecar, or the Dapr daemon as it's called, and I have the traffic control service, which is just my .NET application. And if I look at the logging of that application, here you can see that it is actually receiving these entry and exit messages. And once in a while, sometimes you see something like this. So we get an exit for this vehicle, KF047X, and we see a speeding violation. So this person drove 43 kilometers an hour too fast on this stretch of highway. And for each of these speeding violations, the traffic control service will send a message to the fine collection service. So if we go to the fine collection service and look at its logging, here you can see that all these speeding violations are being sent, and the fines are being sent. The information of the vehicle and the owner, as you can see here, Rolanda Filipek, and the license number and the Seat Ibiza, that's all being retrieved from the vehicle registration service. So if we also go to the final service in the solution, you will see that once in a while, if there's a fine, the fine collection service will get the information for this vehicle. So this is how this works. And these logging is also, this logging you will also see during the workshop to make sure that everything works correctly. And then finally, because we, like I said, we're actually using an SMTP server, and I'm using an SMTP server running within the solution, which is a test server, mail dev. You can actually see mails coming in. Of course, this is all simulated, right? But you can imagine that we could send actual emails to people. And here you can see all the details of the speeding violation. So this person drove 22 kilometers an hour too fast. And yeah, he or she has to pay 183 euros to the Central Fine Collection Agency. So here you can see that these emails actually are being sent by the Fine Collection Service. So with that, this is basically the end of the introduction. So this is what we wanted to show you. So the introduction of Dapr, what Dapr is, and also the sample application that you're going to work on. So all these building blocks you're going to be adding to the simulation. And you actually start with a running application. So you don't have to build anything from scratch. It is actually a running application that communicates over HTTP. And then step by step, you're going to add all these Dapr building blocks. Now, there is two ways of doing the workshop. So every assignment that you do, you can either choose the DIY way or the step-by-step way. And the DIY way is basically, okay, this is what I want you to achieve. So we describe the goal of that assignment. And then you just grab the Dapr documentation. And we also assume that you know a lot about .NET 5, .NET Core. And then you try to make that work. So that is, I would suggest that only if you already have a lot of experience with .NET and with Docker and stuff like that. So if you have a lot of experience with that, you can try the DIY. If you can get it to work or if you get stuck, you can always go back to the step-by-step. And I would suggest that if you are new to Dapr and you want to follow and learn how to apply Dapr, I would suggest to do the step-by-step variant. And this will really meticulously describe what you need to do and why. And by doing that, you will get to the end result of all the assignments. One important thing is that you cannot skip assignments or do them in random order because they build up on each other. So it is important to start by one and end at the last assignment. So I haven't looked at the chat, so I don't know if there are any questions already, but I think now is the time for people that want to follow the workshop to go to this repository that you see here on the slide. So github.com/edwinvw/Dapper workshop. And then from there, it's basically just reading the README files and skipping through the assignments because you can do it all by yourself and on your own pace. If you have any questions during the workshop, or you want to discuss something, or you want to, you need a stretch goal because you did all the assignments within 5 minutes, that's also possible, of course, then please put that in the chat or unmute. For us, it's the more interaction, the better it is. So please let us help us if you get stuck. And what would be really nice is if you start working on these assignments and you have, for instance, finished one, that you post that in the chat, like, okay, I did assignment 1 and it's awesome. And so that we know where people are and we can get a feel of where people are in the room. So I hope that's all clear. And yeah, all I want to say now is also have fun and learn from the workshop to know what Dapper is and how to apply it. And if there's any issues or you need any help, please let us know and then we'll dive in. So with that, yes, happy coding. Have you looked at the chat, Sander, to see whether there are any issues or any questions?
Yeah, no, there are no questions yet in the chat, and I've also shared that repository link in the chat, so that's a little bit easier to click on.
I see that now. So yeah, have we any idea how many people are in the chat right now or are following the workshop? Can we see that somewhere?
Well, I see that there are, well, the Telegram says there are 10 members online, but we know that not that many people join the chat before they have any troubles. So
yeah, exactly.
the workshop, like sometimes we see like it is as low as like 10% of people actually joining the chat compared to the total number of those who are watching it. But as soon as people have troubles, they start joining and start like putting a lot.
They will come streaming in.
Yeah.
Yeah. Well, we'll just leave this slide up so people know the link, even if they're not in Telegram, and then we have to see whether or not we see any issues.
Yeah. So, and a small addition from my end as well to those who are listening: if you can kind of ask questions in any way. It even in theory is okay if you ask in Russian, if it's more kind of easier for you. It's not a problem. I will just translate. I'm also monitoring a chat, and also will try to do the workshop in parallel. I don't know how far I will be, but let's see. So, and I really encourage you, those who are watching us, like, report the progress in the chat. Unfortunately, in this online version, that's the only way for us to know how far you are and if you are doing
and also
things.
What's really important, if there's any feedback on the workshop, so if you find anything that's not clear or if there are any bugs in the workshop, in the descriptions or whatever, please send them back to us because we want to make the workshop better and better. So if you don't understand anything or you need additional description in the text, please let us know because we value all your feedback and this will only make the workshop better and better. So and thanks in advance for all your feedback.
I can say that the initial step works fine. I'm able to get the what's the pronunciation of this word? Vehicle info from my
vehicle information. Yeah,
vehicle information. Thanks. That's the weird English word. Okay.
Yeah.
I've got to learn something new as well here.
So I guess we, I think I will just disable the camera and the mic, and then once there's a question or anything is up, then we can just go online and answer the question.
I think you can just keep the camera on, and we can
That's
ask
fine.
our technical team to remove you from the broadcast if you want to do something else. But anyway, you will be here.
Oh no. That's.
I believe you
fine.
can just.
We can also stay in the picture.
Stay here. It's fine. Just keep it as it is.
It's fine. Keep it as it is.
No, it's fine. People should now do their work with their Visual Studios.
Yeah, they actually have to do work and not listen to people talk. So we hope people like that.
Yeah, I'm also trying to do some work. We may talk a little bit in parallel so that people know that we are still online. But yes.
Are you looking at the question, Sander, or shall I answer that one?
Yeah, you can also answer on air as well in the.
Oh yeah, that's also fine. Yeah. So what's it? So if I want to create a simple component, I have two ways. One, contribute to the official Dapper repositories, or do a fork and build Dapper from scratch. Yeah, both are possible. So there's basically two repositories if you want to add a component. So there's the component contrips repository, and there's the Dapper repository. So Dapper is actually the runtime. So the Dapr that you just saw is part of the Dapper repository. And all the components are held in the components contrib repository. And what you need to do is you have to clone both of these repositories, so fork and clone both of these repositories. And then you're able to create a component in the components contrib repository. And then the Dapr repository, you have to register that component. And then you can build your own version of the Dapr runtime, so the Dapr daemon. And then you can use that to test your component. And once all the tests are succeeded and everything is fine, you can push that to the repository, and then you can create a a pull request, a PR, in the upstream repository, the Dapper repository and the Dapper components contrib repository. And then the team, so the maintainers of these repositories, will look at these pull requests for any errors, and then there will also be a complete build system that does all kinds of tests. And if everything is okay, then they will eventually merge that into the main branch, and then it becomes part of the Dapper. So in the next version, then your building block or your components will be added. So I hope that answered the question. If you, by the way, want to know how to do that, that's also something that we did yesterday in the advanced session.
So yeah, just a little addition to what Edwin just said, that step 2 would basically always be your first step, right? Because even if you want to contribute your component to the community, you would always start by making a fork first and do the development locally. And then if everything works and you're ready to put it out there into the world, then you would create your PR to the upstream repository.
Okay, at least I can see that the HTTP version works. Surprisingly.
Achievement unlocked.
Yeah. I actually was a little bit worried because, well, I have too many lots of runtimes, like different kinds of things, and and I don't have Kubernetes. So when Edwin started showing Kubernetes, I thought, oh well, no, it will not run here. But okay.
Now that's pretty good. That's also a nice thing about the flexibility of Dapper, that you don't need to run it in Kubernetes, but it runs perfect in Kubernetes if you want that power of Kubernetes beneath it.
Yeah,
and that's always the thing with workshops, right? It's always interesting to see what people install on their laptops, and if it's compatible with the workshop assignments that you're trying to complete.
Interesting. Okay, and we have also one of our participants also completed the first assignment.
Awesome.
So, and you shouldn't call it slow, Vladimir. It's not slow. So
it's definitely not.
Oh wow, that's winning a banana. That's the wrong one.
Okay, yeah. More people completed. That's cool.
Cool. And actually, it isn't slow. I think that the last one we did, it took a little bit longer for people to get through the first assignment. So I think it's actually quicker than average.
Definitely.
Well, you may have heard that .next is a conference for advanced developers. Actually, for all developers, but we have a lot of senior developers here. So but on the other hand, every developer will have to learn something. Okay, but that's fine.
Yeah, I know. I've been to .next St. Petersburg twice in person. So I've spoken on the conference before, and I know there's always intelligent questions, and also I really like the discussion zone always at the end. So then the good questions come out.
That's where you can finally grab the speaker and ask the question, and which you may not be ready to ask during the session in the room. But here it's easier. Writing in chat is not as bad as just grabbing a microphone and asking it loud. So
yeah, exactly. Yeah, I really regretted not being able to come actually to St. Petersburg, because I always really enjoy it. But yeah, it's online. What can you do?
I think we need to make some kind of, like, I don't know, interactive progress things visible also online, so that we can see the progress of the whole team, because then it would be much easier to understand where each person is, and try to see any stuck points.
Yeah, that would be nice. I did a workshop a couple of years ago, and in that workshop you were basically all racing toward a common goal, and there was a dashboard which was visible in the room. And then every time you unlocked something, you completed an exercise or an assignment, it would show up on the dashboard. And that's also really nice, because it gives a little bit of gamification to workshop, but people start competing with each other. So that would actually be a pretty good addition to this workshop as well, I think, Edwin, if you can do something interactive like that.
Yeah, we could do that. So
and I know you've got some time off schedule, so you can just use your time off to build that in, right?
No, I've got other things to do, my friend.
Yeah, but you just need to write another Dapper sidecar that will just report okay, now I'm installed in this container, and reporting okay, this person is now using, I don't know, is up to sending emails, and this person is already done, and things like that. So
that is something we can look into.
And the first assignment would be just install this sidecar everywhere, and then as soon as you do that, you are on the board of the participants.
Yeah.
Be fun to implement. Yeah, I'm going to look at that more closely.
That's really cool. And then maybe you have to use some kind of a unique identifier for the workshop, and then you can have a workshop per team, and then also teams can compete against each other. Because we actually did a hackathon last weekend, so Friday and Saturday with 30 people. Everyone working with Dapr. Some people were doing the workshop, other people were actually building something with Dapr to get to know it. And then it's also really nice to see what people are building, people doing little demos and stuff like that. So it really adds to the interactivity of the workshop.
Yeah, but on the other hand, sometimes you need to so one way would be if you make maybe a little bit more complex workshop, not with the 7 assignments or how many it is here, but with I don't know, more advanced things, but then people are grouped into teams and they work in parallel on the same source code. I'm not sure how easy it is to share then the results. You need to do some Git magic to push things, build things, etc. But then it's also interactivity is great, but you also need to have time to really do the work. So otherwise you will not learn anything. So that's the good thing about workshops. Yeah. So you need to do something by your hands before you need to before you can say you know something. Otherwise, it's just watching the talk. And that's it.
Yeah.
And I always find that if I watch a talk, I think I understand it, but then when I try to apply it, it's just a different way of looking at it, and I get different questions in my head. I'm typing this, but what more can I do with it, and how can I do it in different ways? And you just learn more of it.
Yeah, but on the other hand, watching different talks on this, so there is always a balance. You watched a single talk on the topic, and then you just try to dive straight into trying to do something, or you watch multiple talks from different angles, like your Dapr thing. So maybe even if you do not know Dapr, watching the advanced talk might be also of some use, because you understand where you can finally go to. Because the only introductory talk is okay, fine, I can write hello world, but so what?
Yeah.
That never went to production.
Nobody makes profit on hello world.
Well, not every project goes to production. Many courses and workshops are made around we are building just a hello world, but we are building it using some very new technology or the language that you never tried, or things like that, and it's also kind of production to some extent.
Yeah, it is. Yeah.
So let's see. Yeah, we don't need slides anymore because everybody's already working on the code, so it's fine to show 3 of us. And let's see. Not too many people came to the second stage. I mean, nobody yet, at least not reported. But
so let me see. What was the second assignment again? Was it state management, Edwin?
No, this pops up. No, the second assignment is adding. So the first one is getting it up and running. The second one is adding service invocation.
Yeah, I'm always confused because I forget that the first step is just getting it up and running.
Yeah, exactly.
It's an important step. Don't get me wrong.
Yeah, and looking at the second step, I see the diagram which says the name resolution component on it. So is it kind of an absolutely separate component which does the service discovery in the Dapr environment?
Yes, it is, and it is also pluggable. So there are currently 2 different implementations. So if you run in Kubernetes, it automatically uses a component that uses the Kubernetes naming servers to discover where the other pods and sidecars live. And if you run in self-hosted mode, it uses a different component,
MDNS.
which uses MDNS for local DNS broadcasting to make sure that works. And I believe they are working on a third component that uses HashiCorp console for service discovery.
Mm-hmm.
So most of the times you don't need to worry about that stuff because, hey, when you're running Kubernetes, it uses the right component. When you're running locally, it uses the right components. But if you start getting into more specific scenarios, so for example, you want to run Dapr on Azure App Service, then you're getting into trouble because the MDNS will not work on app servers. There is no Kubernetes naming servers on Azure App Servers. So then you need to plug in a different service resolution component that can do the work for you, such as that console component.
But if I'm running on Azure App Service, then it means that I'm not running in the container technically, because I just
yes and no. You can run containers on top of Azure App Servers. So it would be possible. It's not really well supported yet, but it would be possible to create like a Docker Compose file and put in your application container and put in a Dapr container and deploy the Docker Compose file to Azure App Servers. And then you have those two containers running on top of app servers instead of directly pushing your .NET code to Azure App Servers.
Yeah, that was my question, because how then I push the Dapr part of it if it's not in the container? When I'm calling the external code, so as you said, this name resolution thing is for the internal service discovery, but when I'm doing a call to like external HTTP thing, like third-party service, do I get any benefit from using Dapr for it, or it's only for the internal calls?
Yeah, so it kind of depends. That's the usual IT answer, right? If you are trying to call like an external API, which may be a complex API with a lot of logic around it on how to call it, then there might be a binding for it. And then you can use that Dapr binding, which can abstract away that logic. But if you're just simply calling a different web API, so let's say you have a big solution now, and some of the components in your solution you are applying Dapr, but some other older components are not yet Dapperized, and you want to call those APIs, then there's not really any benefit that Dapr can give you there. Then you would just, if we're in the .NET world, you would simply new up an HTTP client and make that call yourself.
Yeah, because I was hoping that, as you said, the Dapr can have some retry logic internally for the service-to-service calls. So why wouldn't I reuse this for the external calls as well, even though technically the other side is not Dapperized yet?
So one of the things they are looking at adding to Dapr is a more comprehensive retry building block, which would also include things like circuit breaker. So I'm not 100% sure that will be something that is a separate building block, or it would just be an extension to the service invocation building block. But it would be nice to have something like that in Dapr. On the other hand, I'm not sure if that solution would make it more easier for you than instead of simply using something like Poly to implement your retries.
Yeah. Well, my goal was like, okay, if I already use Dapr for one part, so why to use another component of like library in case Poly for the other part of the calls?
Yeah, and that's a fair point. I'm just not really sure if it's worth the abstraction. Well, you could envision a service invocation building block that still goes through all of that retry logic and also goes through the Dapper sidecar. So then you do have the observability because that's also a thing that you get for free from using service invocation. But instead of calling a different sidecar, it just goes out and makes the HTTP request for you.
Yeah,
that would actually be a pretty nice scenario, I think.
Yeah. But also you have to make sure that, because like you said, if you have an API that you can Dapperize, you can always, of course, put a simple service in front of it, kind of as a reverse proxy or something like that, that then on behalf of you call this other service, but then Dapperize that reverse proxy. If that makes sense. So you build some abstraction for the other API and you Dapperize that one. And then from that abstraction, you call the HTTP. Because then you can make use of service discovery. It is a secure connection. But from the abstraction to the actual backend service, that is not secure, of course. That's just HTTP. But you could build something in front of it. So that's one of the solutions that you could do.
Yeah,
and also because, for instance, what we did in eShop on Dapr, we've used Envoy, which is a proxy, basically, and we've also Dapperized that. So we didn't have to write any code. It is just a reverse proxy that gets calls and then uses Dapr to call other services, but you could also do it the other way around, of course.
Yeah, okay. Just from a project point of view, I think Dapr was being worked on like maybe a year, maybe even a bit longer in public before we GA'd.
Yep.
And a lot of the focus has been on building a Dapperized application, right? And I think that now that Dapr is at GA and people are starting to use it in production, they will encounter these type of scenarios. They will encounter a lot of scenarios where only a little part of an application landscape is Dapperized, and they need to integrate with the other services. So I think that now there will be more emphasis on, okay, so how do we do these integrations? And we will probably see some additions and extensions to Dapr to make it easier to work with in those type of scenarios.
Yeah, but it starts to a little bit looking in as a kind of a magic that we have in the old days, like transparent RPCs like WCF and everything. Like you just do the call and then it's like magically transferred to the remote thing, being it another Docker container running in the next pod, or it's a third-party server running elsewhere without any guarantees of the like how far it is and how long it will take to reach it. So it's also kind of a little bit tricky area, kind of how to approach this.
That's one of the things that's very true, that you don't know where everything is, right? So usually your Dapperized solution is contained to a single Kubernetes cluster, right? You're using it in a single application, you deploy that to a Kubernetes cluster. But then it's absolutely true that you have to remind yourself that any call to like a different service could be a cross-node call. And that's also true with if, for example, we don't go into that in this workshop, the actor building block. But if you use the actor building block and you want to call an actor, that actor may be co-located on the same node, or it could be on an entirely different node in the cluster. So you really have to take care of that and to make sure that you're okay with the latency. Then of course, the latency is pretty low if you stay within the cluster. And then also the sidecar calls will add a little bit to that latency because you're not making a direct service call, but you're going through sidecars. And they did some extensive testing on that. And it's basically in the single digit milliseconds. But still, it's better suited for more general enterprise applications than really highly specific, highly performant applications.
Okay, thanks. So we'll see. I don't know if we have maybe half a minute to quickly answer the question in chat about RabbitMQ container as being a prerequisite. I think I saw it running on my machine. So and I didn't have it before I started doing the workshop. So hopefully Dapr installs some default one.
Yeah, because I think during the workshop, you will just pull the RabbitMQ container from the Docker Hub. So if you follow the instructions and you have Docker Desktop running, then it should be fairly fast and quickly to get it up and running. So let's dive into that. Why that should be a prerequisite?
Well, one thing I could think about, I think that as a prerequisite, is that if you know it's a prerequisite and you have a slow internet connection, then maybe you can pull those containers to your local machine before you go into the workshop. So that would be a benefit. Just like Krakow says, if it's not installed, it will get it from Docker Hub. But I totally understand the point about maybe if you have slow connection, you want to know upfront what kind of images are being pulled to a machine.
Yeah, I could add something to the prerequisites to say, okay, we're going to use these containers, so make sure you already pull them and then they're on your machine. So that would be a good addition. Thanks for that. We'll add that to the description.
Okay, and now we have Michael with us. It means like it's time to complete this first part of our...
Yeah, hi guys again. I think we continue your workshop after partner block. See you later.
Yes, see you later.
See you later.